Picture yourself standing deep within the canopy of the Bornean rainforest. The air is intensely thick, heavy with humidity, and you can smell that rich, earthy sense of damped wood and fungal decay. You're observing a rough patch of bark right in front of you, when suddenly, a tiny reddish-brown insect, no larger than a grain of rice, is intercepted by a much larger predatory weaver ant. Now, the smaller insect doesn't run. It doesn't even attempt to bite. Instead, it stops dead in its tracks, locks its legs onto the wood, and violently arches its back. In a fraction of a millisecond, that tiny ant flexes its abdominal muscles with such impossible force that its own exoskeleton simply cannot contain the pressure. It rips itself apart from the inside out. A sudden rupture. A fatal spray of bright, toxic yellow goo erupts in all directions, completely engulfing the attacker. The predator is instantly paralyzed, glued to the bark, and actually begins to corrode. The smaller ant is dead, but its colony is safe. Okay, so what you just witnessed is absolutely one of the most extreme evolutionary defense mechanisms on planet Earth. This unassuming little insect is a minor worker of a species called Colobopsis explodens. For decades, biologists actually grouped it under the Camponotus Saundersi species complex. But during an expedition between 2014 and 2016, researchers realized this specific ant was entirely distinct, and they officially described it as Colobopsis explodens in 2018. Honestly, you wouldn't think this ordinary-looking forager is a walking suicidal time bomb. But the moment a territorial dispute escalates, this minor worker raises its posterior, exactly like we just talked about, and pulls the ultimate biological trigger. Now, what makes this society so deeply fascinating is the stark contrast you find within the colony itself. Because surprisingly, not all of these ants explode. Meet the major worker. They have this massive, flattened, completely plug-shaped head. In the world of Colobopsis explodens, these heavily armored majors are the doorkeepers, and they almost never leave the nest. Their absolutely sole job is to sit inside hollowed-out tree branches and perfectly wedge their bizarre heads into the nest entrances. They act as literal living doors to physically barricade against intruders. It's only the expendable, younger minor workers, the ones out foraging, who handle the extreme dangers of the outside world. When those minor workers are pressed, they engage in a phenomenon with a very specific and highly terrifying scientific name: autophysis. Now, autophysis literally translates to self-sacrifice or self-destruction. But you have to understand this isn't some passive death. It is the active, aggressive rupturing of an internal organ. The ant effectively weaponizes its own anatomy. And the sheer biomechanical physics required to make an exoskeleton burst open on command like that, it's nothing short of astounding. So the absolutely crucial point here is the speed. Researchers using high-speed cameras at the University of Würzburg actually managed to clock the exact duration of this detonation mechanism. From the very moment the ant violently contracts its abdominal muscles to the moment its gaster tears along the intersegmental fold, it takes less than 1 millisecond. Let that sink in. Under 1 millisecond. The human eye literally cannot even begin to register this movement. It's a sub-millisecond biological detonation powered entirely by internal muscular pressure. To really understand how this explosion works, we have to look inside the ant. And when biologists first looked inside, they basically couldn't believe the anatomical burden this animal lives with. See, most ants have mandibular glands. They use them to produce tiny amounts of alarm pheromones or digestive juices. But in Colobopsis explodens, these glands are completely hypertrophied. They have swollen into massive oversized bladders that run the entire length of the insect's body, from its head all the way down to its bulbous abdomen. To put this into perspective, imagine a human walking around with 2 fully pressurized water towers shoved inside their chest and throat. That is the intense physical reality this ant carries every single day. For years, the true nature of this yellow goo was a complete mystery to field researchers. It's not just a simple poison. When we run the forensic chemistry of this secretion through a spectrometer, the results are honestly mind-bending. We're looking at a crazy cocktail of over 45 complex, volatile organic compounds. There are these intricate structures like MAPG and noradrenaline. We're talking about highly specific phenolic compounds and acyclic monoterpenes. It's an incredibly sophisticated biological payload that evolution has spent millions of years refining into the absolute perfect chemical weapon. Let's actually break down exactly what that payload does the moment it hits the air, because it operates on multiple devastating levels simultaneously. First, it's an entangling, sticky glue that physically immobilizes the enemy. Second, it contains corrosive contact toxins that act as a severe chemical irritant. Third, it releases a massive cloud of volatile alarm pheromones, instantly alerting every single other ant in the vicinity that the colony is under attack. But it's that last point, the phenolic acid of phenones, that completely changes how we understand this explosion. This is the final piece of the mystery falling into place. This is where the story pivots from a straight-up military defense to a medical mystery. Is this yellow goo a weapon, or is it a pharmaceutical? Well, recent studies reveal that these specific phenolic compounds in the yellow goo are incredibly potent antimicrobials. You see, in the warm, wet, fungus-heavy environment of the Bornean rainforest, pathogens are just as deadly to an ant colony as a rival insect. So when an ant explodes, it doesn't just kill an enemy, it effectively coats the surrounding area in a chemical disinfectant. Every single suicidal detonation leaves behind a protective smear of antibiotics, shielding the colony's foraging trails from deadly fungal infections. How crazy is that? But you might be wondering, why would any organism evolve to kill itself in the first place? To understand this, we have to look at the incredibly ruthless rules of survival. When massive, overwhelming threats like army ant raids sweep through the forest, conventional biting or stinging just fails against sheer numbers. A solitary wasp facing this would be completely doomed. And if that wasp is killed defending its nest, its genes die with it. It's a complete evolutionary failure. But a eusocial ant worker? She's sterile. Her reproductive future relies entirely on her mother, the queen. If she dies, but her explosive death saves the colony from an invading swarm, her genes live on. In the grand scheme of things, her death is nothing more than a minor operational loss. The legendary biologist E.O. Wilson actually explained this through a concept called series parallel operations. In human terms, it's a lot like a highly redundant factory line. A solitary insect does tasks in a series, meaning if one step fails, the whole process fails. But an ant colony does tasks in parallel. If one exploding ant detonates and dies, another identical worker instantly steps right into her place on the foraging trail. The system effortlessly absorbs the suicidal loss of individuals without the entire society collapsing. As E.O. Wilson famously stated, for the most part, the unit of selection is the colony rather than each of its individual members. This is really the core of kin selection pushed to its absolute most dramatic extreme. The individual ant does not truly matter. Nature isn't testing the survival skills of the single worker, it is testing the survival skills of the entire colony as one massive, distributed entity. Which leads us to a pretty profound realization. When a Colobopsis explodens worker spots a predator, locks its legs, and tears its own body apart in a spray of toxic, antimicrobial yellow goo, we really shouldn't look at it as an individual animal dying. Instead, think of the entire ant colony as a single superorganism. That exploding ant is simply a white blood cell rushing to the site of an infection. It bursts to destroy the invader, disinfect the wound, and protect the greater body. It is nature's most extreme sacrifice, perfectly calculated. It really forces you to question what true individuality even means when you look closely at nature, doesn't it? Well, if you want to keep unraveling these incredible biological mysteries with me, make sure you hit subscribe to this explainer. You absolutely won't want to miss our next topic, where we'll be exploring the mind-bending neurochemical surgery performed by the zombie cockroach wasp. I'll see you there.